What's up? I'm Vin, and I'm going to go through the January 2024 Algebra 2 Regents, and I'm going to do the parts 2, 3, and 4 questions. I'll leave a link to a copy of this test in the description below. So first up, we have the part 2 questions. They're worth 2 credits each, and question 25, we want to factor this polynomial completely. So for this one, we're going to do factoring by grouping. I'm going to take the GCF out of the first 2 terms and then the second 2 terms. So between x to the third and 4x squared, we have a greatest common factor of x squared. And now the math that I'm doing in my head is I'm taking the terms and dividing them by the greatest common factor. So I'm doing x to the third divided by x squared, and I'm doing 4x squared divided by x squared. And if I do x to the third power divided by x squared, I have x. And then next, when I do 4x squared over x squared, I get plus 4. So that's our leftovers here in the parentheses. But now when I factor out a greatest common factor out of the second 2 terms, I have to be strategic here. I have to take out a factor that's going to give me a matching binomial. So if I were to take out 9, that's a problem because I'm going to have negatives left over. But watch what happens when I take out negative 9. If I do negative 9x divided by negative 9, I'm going to have a positive x left. And if I do minus 36 divided by negative 9, that's going to give me a leftover of positive 4, which is what we want. We want to have matching binomials. That's how we know we're factoring by grouping correctly. Okay, you should have a match because that allows you to go to the next step. So now we're going to take out the x plus 4, and the leftovers here are going to be x squared and minus 9. Now, if you stop here, you're not answering the question completely. Okay, when I hear factoring completely, that just tells me that I'm probably going to have to factor once more. So now the next thing that I'm thinking about is a squared minus b squared. When we have a difference of 2 perfect squares, this factors nicely to a plus b times a minus b. So this now I could write as x plus 4 times I have x plus the square root of 9 is 3, and then times x minus the square root of 9 is 3. Okay, so I'm just using this difference of 2 squares formula to make sure that we actually factor this completely. But here is our solution to question 25. Question 26, we have to determine if x plus 4 is a factor of this polynomial, and then we have to explain our answer. So for this one here, what I want to do is I'm going to divide this polynomial here by x plus 4. And if it divides evenly, then that tells us that x plus 4 is a factor of this polynomial. So that's the route I want to go here, and I'll use synthetic division. I'm going to write the coefficients here. So we have 2x to the third, then we have 10x squared, we have a 4x, and then we have a minus 16. And now what we do is we write the root that would come from this factor of x plus 4. So for this part, the math that I'm doing in my head is I just imagine I'm setting x plus 4 equal to 0, and the solution to this equation would be x equals negative 4. So I write my negative 4 on the outside, and now I could start the process. I bring down the 2, and I have negative 4 times 2 is negative 8. And then I do 10 minus 8 is positive 2. And I do negative 4 times 2 again, I get negative 8. And now I have 4 minus 8 is negative 4. And now I do negative 4 times negative 4 is positive 16. And this gives us no remainder. So then what this tells us is that we could factor 2x to the third plus 10x squared. And then we have plus 4x minus 16. This factors nicely to x plus 4 times, and now what we had from the synthetic division is our polynomial that we're going to write on the inside. So since we divided an x to the third polynomial by an x factor, we're going to be left starting with an x squared coefficient. So we're going to have a 2x squared, then we're going to have a 2x, and then we're going to have a minus 4 at the end. Okay, if we had a remainder, then I would just have to write my remainder over the original divisor was x plus 4. Okay, but we could even check this if we wanted to distribute, but this polynomial breaks down nicely to this. So is this x plus 4 a factor of this polynomial? We're going to say yes, because it divides the polynomial evenly. Now, one thing I just want to point out here, anytime you have a question and they're telling you to explain, make sure that you write some sentence at the end, because that is an annoying way to lose out on a question like this. But this explanation would get us full credit. Now, one more thing I want to point out is if we just type in the polynomial that we started with, so we had 2x to the third, then we had plus 10x squared, we had plus 4x, and then minus 16. And we go to the table here. So we press second graph and go to our table. When we did the synthetic division before, x plus 4 equals 0 gives us a root of x equals negative 4. If we look at the table at x equals negative 4, notice that we have a root. So if x equals negative 4 is a root of this polynomial, then that tells us that x plus 4 is a factor of this polynomial. So that's a different approach to getting full credit to this question, but we could have also analyzed the fact that x equals negative 4 is a root of this polynomial, but doing this synthetic division and showing that the polynomials divide evenly also gets us full credit. Question 27, an initial investment of $1,000 reaches a value v of t according to the model v of t equals, and we have this function here, and t is the time in years, and we need to determine the average rate of change to the nearest dollar per year of this investment from year 2 to year 7. So what we need to know here is that the average rate of change formula, when we have some function, so we'll just think about this. We have some function f of x, and we're on the closed interval AB, then the average rate of change, I'll just abbreviate this with AROC, is going to be f of b minus f of a divided by b minus a. This is basically the slope formula. So the visual concept behind this is that if I have some function f of x, and let's say this is going from a to b, and this is once again f of x, f of b minus f of a over b minus a is the slope between these 2 points here. Okay, so that's basically what we're looking for. That's the average rate of change. So in this function here, we're looking at t is the time in years, and we're finding the average rate of change from year 2 to year 7. So this is basically telling us to do v of 7 minus v of 2 divided by 7 minus 2. And for this, we just plug into the calculator. So we'll go over to the y equals here, and we'll type in, we have 1,000, and now the base of our exponent is 1.01, and we're raising this up to the 4t power. Now, for this one, what we're going to do is we could just look at the table at 2 and 7. So I could scroll down and see at year 2, I have this amount, and at year 7, I have this amount. So I could just copy these values down and subtract them. But there's a nice way with the TI-84 plus CE. If I want to type this in with this notation, I press alpha y equals enter, and I saved v of t in the y1 spot. So if I go to my fraction here, I could go and press alpha trace, and there's y1. And now if I put parentheses 7, the calculator is going to read this as v of 7. And now I can press minus, and if you have an older version of the TI, then you could press vars, go to the right, and then you go to function, and y1 is waiting for you. But the alpha trace just gets you to y1 faster. And I put parentheses 2, and now this is reading v of 7 minus v of 2 over, and we'll pretend we don't know 7 minus 2 is 5. And we press enter, and here is our average rate of change. So now we could just record our answer, and we're rounding to the nearest dollar per year. So we're going to say that the average rate of change is equal to, and we have $48 because we have 47, and then to the right is a 6, so we're going to round this up to 48. So we have $48 and then per year. So here is our average rate of change for this question. Question 28, we have this expression here, and we want to know when it's written in the form y to the n, what is the value of n? And we have to justify our answer. So for this one, what we really need to do is just do a bunch of algebra to simplify this into the form y to the n power. Okay, so we just have to know all of the properties of exponents here. So the ones that come to mind are the rational exponent formula. So when I have something like, let's say, a to the b over c, this is the same thing as the c root of a to the b power. And I also note here that we're going to have to do division at some point. So if I have a to the b divided by a to the c, that's going to be a to the b minus c. Some people remember this as power over root. So when you want to go from exponent form to radical form, then you write the root in front of the radical and you write the power on the inside. The power b, just know, can go in more than one location. I could write the power b here, or I could even write it on the outside like this if I put this part in parentheses, but I prefer to write it like this. So now I'm going to apply that first property here. So I'm going to do, on the inside, we're going to have 1 over, and we're going to have y to the power 2. So here's our power, and I'll just get that out of the way a little bit. So we have the power is 2, and the root is 3. Okay, so we're going to use that power over root formula, and we're going to write this as y to the 2 over 3. And now we're multiplying this by y to the 4. If I call this y to the 4 over 1, now I'm multiplying two fractions, and this is going to simplify to 1 times y to the 4th is y to the 4th, over y to the 2/3 times 1 is y to the 2/3. So now from here, I'm going to use that second property. When we divide, we can combine these exponents into a single term by subtracting the exponent. So I have y to the power 4 minus 2/3. And now from here, if you want to just use the calculator to subtract, you can, or just think about how do we simplify fractions when we're subtracting. We need common denominators. So I'm just thinking this is 4 over 1. And if I do 4 over 1 minus 2/3, I would need a denominator of 3 for both of these in order to subtract. So I would multiply that first fraction by 3 over 3, and then you get 12 over 3 minus 2 over 3, and that's going to be equal to 10 over 3. But this part, we don't actually have to show the work. We could just say that this simplifies to y to the 10/3 power. Okay, but the actual question here is stating the value of n. So when we get this in the form of y to the n, we just have to identify the exponent, and the exponent here that we get is 10 over 3. So we're going to say that n is equal to 10/3. And here's our solution to question 28. Question 29, the heights of the members of a ski club are normally distributed. The average height is 64.7 inches with a standard deviation of 4.3 inches. And we need to determine the percentage of club members to the nearest percent who are between 67 and 72 inches tall. For a question like this, we just have to do everything in the calculator. So we want to go to second VARS, and then we're going to go to normal CDF. So what we're going to do here is we're going to write for our lower bound, that's going to be 67 inches. Okay, so we want to know what percent of people are between 67 and 72 inches, and that's based on the people here that we're dealing with. So we're going to go lower 67, upper 72. And now for the next part here, we have the average. The average is 64.7, so that goes next. And then the standard deviation is 4.3 inches. So for this question, you can just get away with just doing everything in the calculator, and then we just press enter, enter, and I'm going to press enter again, and then this is going to give us all the information we need. For the actual regions, I would write down normal CDF, and I would write down all of the values exactly as they appear in the calculator. So I would write 67, and then comma 72, and then we have our average is 64.7, and we have our standard deviation is 4.3. And then we could say here that this equals, and we write down the decimal, we have 0.25, and then I'll stop at 158. And then from here, what I'm thinking of is how do we convert a decimal to a percent? So when we want to convert a decimal to a percent, we multiply by 100. So here in my head, I'm doing 0.25158, and I'm multiplying it by 100. And that would move the decimal 2 places to the right, giving us 25.158. And now we have to round to the nearest percent. So we look at the whole number here, or the ones place, the 5, and to the right is a 1, so we're going to round down to 25%. This is all we have to show to get full credit. Now, one last thing before we move on. The concept behind what's going on here is we have a normal bell curve. So I'm just thinking of a curve like this. So we have our bell curve. And at the center of the curve, and I'll make this as neat as possible, I want this to be symmetric. So let's see, one more time. And sure, that one will do. So here at the center, this represents our average value. And our average value here is 64.7. And then as we go forward 1 standard deviation, or we go backwards 1 standard deviation, we would add or subtract 4.3. So if I add 4.3, I'm going to get 69 over here. And if I go backwards 4.3, that's going to bring us to 60.4. So we could see here when they ask us what percentage of the members of the ski club are between 67 and 72 inches tall, notice that 67 is somewhere over here. And if we look, 72 is a little bit past this. It's not quite 2 standard deviations forward, because if I go forward 4.3, that's going to send us to, we'll have 73.3. Okay, so that would be the next value here if I added another 4.3 going this way. So we have 67 is going to be somewhere over here, and then we have 72 is somewhere over here. So we want to know what percent of the bell curve is covered by this amount. And that's what the 25% actually means. When you are between plus or minus 2 standard deviations, so you'll need this information later, plus or minus 2 standard deviations is 95%. Okay, that's the middle 95%. But when we're just talking about this little section over here, that's 25%. Now, this is not something that we could calculate by hand unless we have really fancy formulas or we have a reference page. That's why it's accepted to use technology here. So that's the actual meaning of the 25%. It's referring to this portion of the bell curve. Question 30, the explicit formula A sub n represents the number of seats in each row in a movie theater, where n represents the row number. And we want to rewrite this formula in recursive form. Okay, so for something like this, what I would do is just write the first few terms of this sequence. So if I were to plug in n equals 1, I would have 6 plus, and then I have 6 times 1 is equal to 12. So this is the first term of our sequence. And then if I plug in 2, we would have 6 plus 6 times n equals 2, and that's going to give us 6 plus 12, which is 18. And if I do this one more time, we're going to have 6 plus 6 times, and now I'm replacing n with 3. And that would give me 18 plus 6 is 24. So then the thought process here, when we're going from the explicit formula to the recursive, is we have to identify the pattern here if we list these numbers out. And you want to think about, how do you get from one number to the next? Well, to get from one number to the next, you're just doing plus 6 each time. So I would do plus 6 to get from 12 to 18, and I would do plus 6 to get from 18 to 24. So that's going to help us build our recursive formula here. So the recursive formula, I'll just write over here. We're going to say the recursive is equal to, and over here, we're going to have a sub 1 is our first term is equal to 12. And then our rule, a sub n, is going to be equal to the previous term plus 6. So just think about that very carefully. Anytime I want to get a term here, let's say I'm thinking of 24, I'm using the previous term 18 and then plus 6. Recursive means using the previous terms. Okay, so just think of the word previous. One way to remember this is, if you ever heard the phrase recurring nightmares, is when you have the same nightmare over and over. It's built off of the previous nightmare. Okay, so hopefully you don't have a nightmare hearing that. But when we're thinking recursive formulas, just know that it's built off of the previous term. So if I'm at the a sub n term, I would use the term before it is a sub n minus 1. And then what's the pattern? I take the previous term and I add 6 to it. Okay, so this would be our recursive formula for this sequence here. Now, if that didn't make sense, just look at the explicit formula that I have up here and look at the terms that we got. If I try this formula out, let's say I plug in something like n equals 3. N equals 3 would give us a sub 3 equals, and I would have a sub 3 minus 1 is 2, and then plus 6. And if we look at these values here, a sub 3 is 24, and this is equal to a sub 2 is 18, and then plus 6. So you can see that the formula does check out here. So this recursive formula will get us full credit. Question 31, we want to express this in simplest form. So if we start off here with I to the 0 equals 1, next we would have I to the first is equal to I. And then I to the second is equal to negative 1. And now to get future values here, I could just multiply both sides by I. If I do I times I squared, that's going to give us I to the third power on the left side. And if I multiply the right side by I, I'm doing negative 1 times I, that's going to give us negative I. So the next thing we would need to know here is that I to the third power is equal to negative I. And then if we go one more here, if we go to I to the fourth, the pattern is just going to start to repeat itself. The pattern is every 4 terms, this repeats. So watch, if I do I times I to the third equals, and then I multiply this side by I have negative I times I get I to the fourth equals negative I squared. But I squared we said is negative 1, so we get I to the fourth is negative 1, which is positive 1. Okay, so for this, you could just know that this is what's going to come next, but it's nice to see where all this stuff comes from. And then once again, once we get here, the pattern is just only going to repeat itself. Okay, the pattern is every 4 terms, we have 1i, negative 1, negative I. So if I had to find what's I to the 5th power, I to the 5th power would be equal to I. Okay, and then I to the 6 would bring us to the next one, which would be -1. One thing to point out here, there is a nice trick that you could use with remainders. If I had something like, let's say, I to the 102, what I do is I do 102 divided by 4. And if I do the division here, 4 goes into 10 twice. 2 times 4 is 8. I subtract, remainder 2. And then I bring down that 2. 4 goes into 22. I could get as close as 4 times 5, which is 20. So I do 5 times 4 is 20. I subtract, and my remainder is 2. Whatever my remainder is corresponds to the power of I in the first 4 over here. So that would correspond to I squared, which would give us -1. Okay, so I to the 102 is equal to -1. We just use this remainder trick. Now, I'm only bringing this up because in this question, that is going to be a big idea that we're going to need. So now let's expand this. Since we have a binomial squared, we're going to write 2xi to the 3rd minus 3y, and then we're going to do times the same thing, 2xi to the 3rd, and then minus 3y. So now we just have to do the distributive property here. We're going to do 2xi to the 3rd times 2xi to the 3rd. Well, 2 times 2 is equal to 4. And then we're doing x times x is x squared. And then I to the 3rd times I to the 3rd is I to the 6. We're just adding the exponents together. And now we distribute to the last term. So we're going to go 2xi to the 3rd times minus 3y. So 2 times -3 is -6. We have x times y is xy. And then we have I to the 3rd is just tagging along. And now we distribute the minus 3y. We have 2 times -3 is -6. We have x times y is xy. And then we have I to the 3rd is just tagging along. And then finally, for the last term, we have plus, because we're doing a negative times a negative. And then we have 3 times 3 is 9. And then y times y is y squared. So now we're going to use what we have over here to help simplify. So for this part, I to the 6 is equal to -1. So I could write 4x squared times -1. And then I have minus 6x. And then we have y, I to the 3rd is equal to -I. So I have minus I like this. And then we have minus 6xy. I to the 3rd is still -I. And then we have our plus 9y squared. And then we just simplify this more and more. So this is going to give us minus 4x squared, because we're doing 4x squared times -1. And then here I have a negative times a negative is positive. So I have plus 6xyi, and then we have a plus 6xyi, and then we have plus 9y squared at the end. So now we can combine like terms. I'm going to do 6xyi plus 6xyi, and that's going to give us, in the next line, 12xyi. So these are the terms that we have together. And then I'm going to write our -4x squared, and then plus, and then we have at the end plus 9y squared. And now for this, what I like to do is write the real part with the real part, and the imaginary part I put at the end. So this now will say our final answer. I'm going to put the 9y squared first because it just looks nicer, I think, if we lead with a positive term. So we have 9y squared minus 4x squared. This is the real part. And then we have plus 12xyi. So here is the expression in simplest form. Question 32, a survey was given to 1,250 randomly selected high school students at the end of their junior year, and the survey offered 4 postgraduate options. We have a 2-year college, 4-year college, military, or work. And of the 1,250 responses, 475 chose a 4-year college. And we have to state one possible conclusion that can be made about the population of high school juniors based on this survey. So for this one here, the first thing I would look for is what is the percent of high school juniors that chose a 4-year college. So we were told that 475 of the 1,250 randomly selected high school students chose a 4-year college. So I would just find this percent. So we'll just type in 475 divided by 1,250. So we're doing the number of people that chose a 4-year college divided by the total number of people surveyed here. And that gives us 0.38. But as a percent, we just multiply 0.38 by 100. And this tells us 38% of the juniors that were surveyed said that they would choose a 4-year college. So now let's show the work. We're going to write 475 divided by 1250 is equal to, and we could just write this directly as a percent. We could say this equals 38%. So now we just have to write our sentence. We have to state one possible conclusion that could be made about the population of high school juniors. So we could say, based on this survey, about 38% of high school juniors plan on attending a four-year college. And then the other 62% is the missing percent that makes 100. The 62% of the juniors in the survey here will choose some other option. Now, the big idea for this question is that we are stating a possible conclusion based on the survey. Okay, so this is all coming from the survey. That's where we're getting this 38% from. But this response would get us full credit. So now we move on to the part 3 questions, and every question here is worth 4 credits. Question 33, we have a researcher wants to determine if nut allergies and milk allergies are related to each other. And the researcher surveyed 1,500 people and asked them if they are allergic to nuts or milk, and the survey results are summarized in the table below. And first, we have to determine the probability that a randomly selected survey respondent is allergic to milk. So for questions like this, what we could do is we could find the totals in each row and column. So here, if I do 3 plus 12, this tells us that we have 15 people here in total when we're talking about the number of people that are allergic to nuts. The number of people not allergic to nuts, if we add 1,443 and 42, that's going to give us 1,485. Okay, so there are 1,485 people that are not allergic to nuts, but 15 people that are allergic to nuts. And now if we find the total, we add 1,485 plus 15, that tells us that there are 1,500 people in total that are in this survey, which matches what they told us in the beginning. So now if I find the total in each row, if we do 3 plus 42, this is 45. This is the number of people that are allergic to milk. And then the number of people that are not allergic to milk, if we do 1,443 plus 12, that's going to give us 1,455. And notice when we add 1,455 plus 45, that also gives us the same total of 1,500. So these numbers are looking good, but I like to do this ahead of time because when we have to find these probabilities, we need to know the totals here. So what is the probability that a randomly selected survey respondent is allergic to milk? So I'm focusing over here, allergic to milk, and we have that there are 45 people are allergic to milk. That's why we find this total here. We're adding 3 plus 42. But that's out of the 1,500 people total. So I'm doing 45 divided by 1,500. So now we could just type this in. We have 45 divided by 1,500. And we press enter here and we get the decimal value. But if I multiply by 100, this tells us our answer as a percent, that there is a 3% chance that somebody in this survey is allergic to milk. So we'll just record this result. The probability that a randomly selected respondent is allergic to milk is 3%. So we'll just write this. Here is our answer. For the second part of this question, we have to determine the probability that a randomly selected survey respondent is allergic to milk given that the person is allergic to nuts. So for this one here, we have conditional probability. And the restriction here is that we are only focusing on people that are allergic to nuts, which means we are only looking in this column here. So we'll just make this neat. We're looking over here in this column. And if we just look in this column here, how many people in this column are allergic to milk? There are 3 people that are allergic to milk, and there are 15 people in total that are allergic to nuts. So here, the probability, we have 3 over 15. And for this, we could just type it in the calculator, but we could reduce this fraction. If we divide the top and bottom by 3, we're going to get 1/5, and then 1/5 as a percent is 20%. So right away, we could see that the moment we add the restriction that the person is allergic to nuts, there is a higher probability that the person is going to be allergic to milk. So now for the last part of this question, based on the survey data, we're going to determine whether nut allergies and milk allergies are independent events. But think about what we just found before. We found the probability that a randomly selected person is allergic to milk was 3%. But then the moment we added the condition in that the person that we're selecting from is already allergic to nuts, that percentage jumped way up to 20%. So just looking at this here, we could see that someone is more likely to be allergic to milk when we know for sure that they are allergic to nuts. So that would tell us that these events are not independent. Now, one last thing I want to point out here, there is a more formulaic way to answer the last part. If you just want to use this formula, that the probability of A is equal to the probability of A given B has occurred, you could use this formula to show that these two events are not independent. So the probability of A would represent the probability that someone is allergic to milk, which we found to be 3%. But then we also found in the second part the probability of A given B has occurred if B is that the person is allergic to nuts. So the probability that someone is allergic to milk, given that they are allergic to nuts, is 20%. And notice that these 2% here are not equal. So since these 2% here are not equal, that would tell us that these two events are not independent. Okay, so these events here do depend on each other. So what that means is that if someone is already allergic to nuts, we know that they're allergic to nuts, there is a higher probability that they are going to be allergic to milk as well. Question 34, algebraically solve for x, and we have this equation here. Now just know that if you can't do the algebra for a question like this, and you use a calculator instead, but you explain how you use the calculator, let's say you just sketch the graph that you use, you would get 2 out of 4, which is better than getting 0 out of 4. So if you can't do the algebra, even if they tell you to do this algebraically, you could still get half credit for something like this. But let's say we do want to do the algebra. We're starting off here. We have 2x, and then this is equal to, we have 6 plus 2 times the square root of x minus 1. For this, we're going to start by going minus 6 on both sides. And the reason why we're doing this is we want to get the radical term by itself, because eventually we're going to square both sides. But before we square both sides, we need the radical term alone. So 6 minus 6 cancels, and now we have 2x minus 6 is equal to, and we have 2 times the square root of x minus 1. And now from this step, we could square both sides. So we're squaring the left side and we're squaring the right side. Now, one thing that students will struggle with is when they have to square a term that has 2 terms on the inside that are attached by multiplication. Like let's say I have something like AB, and it could be squared, or it could even be to the c power. I raise each term individually to that power. Okay, so here, the math that I'm doing on the right side is I'm doing 2 squared, or 2 times 2 is 4, and then I'm doing radical x minus 1 times radical x minus 1 is x minus 1. So that gets us to the next line here. And now on the left side, I have to be careful. I have to make sure that I expand this properly. I'm doing 2x minus 6 times 2x minus 6. So now for the next step here, we're going to distribute. We have 2x times 2x is 4x squared. And then we have 2x times minus 6 is minus 12x. And then if we do negative 6 times 2x, that's going to give us another minus 12x. And then negative 6 times negative 6 is positive 36. And on the right side, we can distribute the 4. We're going to have 4x, and then we have 4 times negative 1 is negative 4. And then from here, what I want to do is get everything to one side. So we could first combine like terms, but if you're comfortable doing all of this algebra at once, you could just do minus 4x on both sides, and then you could do plus 4 on both sides. And notice that I did minus 4x, and I wrote the minus 4x with the other x terms, and I wrote the plus 4 with the other constant term. So now on the right side, everything cancels nicely, and we have 4x squared. And now we have these 3 integers here. We have negative 12 minus 12 minus 4. So negative 12 minus 12 is negative 24, and negative 24 minus 4 is negative 28. So we have negative 28x, and then 36 plus 4 is 40. So we have plus 40, and now this is all equal to 0. So from here, what I would do is I would factor out the greatest common factor, which is 4. So we have 4 times, and then we're left with x squared minus 28 divided by 4 is 7. So we have minus 7x plus 40 divided by 4 is 10. And now we set this all equal to 0. So now we're going to factor, and we need 2 terms, or 2 numbers, I should say, that have a sum of negative 7 and a product of positive 10. And if you think of it carefully, the 2 numbers are negative 5 and negative 2. So I have 4 times x minus 5, and then we have times x minus 2. And we could even see here, if we add -5 plus -2, we get -7. And if we multiply -5 and -2, we get +10. So now from here, what we're going to do is set each of these factors equal to 0. So I'm setting x minus 5 equal to 0, and I'm setting x minus 2 equal to 0. Don't waste your time by setting 4 equal to 0. If you do 4 equals 0, that's just a ridiculous statement. So you don't need to set the constant on the outside equal to 0, just the x factors. So now from here, we're just going to go +5 on both sides. And our first potential answer is x equals 5. And then we're going to go +2 on both sides. And our second potential answer here is x equals 2. But be careful here. Don't say that these two values of x are your solutions. Before we move on, we actually have to check our answers here. So we have to plug these values of x back into the original equation that we started with. So first we'll check x equals 5. And if we plug in x equals 5 to the original equation, we have 2 times 5. We're replacing x with 5. And we're going to see, is this equal to 6 plus, and then we have 2 times the square root of x equals 5, and then we have -1. So when we work this out, 2 times 5 is 10, and this equals 6 plus 2 times the square root of 4. And the square root of 4 is 2. 2 times 2 is 4, and 4 plus 6 is equal to 10. So this one here does check out. So we could say that x equals 5 is a solution. And now the next one we need to check is x equals 2. So if we plug in x equals 2, we're going to have, when we plug in x equals 2, we have 2 times 2, and then we have equals, and we're doing 6 plus 2 times the square root of, and we have 2 minus 1. So now we just have to simplify this. So we'll give ourselves a little space. This is going to give us, we have 4 equals, and we have 6 plus, and then 2 times the square root of 1. But this is going to give us 4 is equal to 8, which is not true. Okay, so this is not true. So this tells us to reject x equals 2. Our only solution here is x equals 5. Take a moment to read through question 35. So for this question, we're going to need the following formula. We need to have the compound interest formula, and we need to be able to account for the fact that Adam and Betty, their bank accounts are going to compound monthly and they're going to compound quarterly. So we need this formula here, A equals P times, and in parentheses, we have 1 plus R divided by N to the NT power. Okay, so this is the compound interest formula that we're going to use to write their functions. So here, what we have to be able to think about is for Adam, let's think about Adam first. We have Adam's account is growing at a rate of 2.4%. So we have 2.4% compounded monthly. So N represents the number of times that the account compounds per year. So if Adam's account compounds monthly, that would mean N is equal to 12. Okay, because if Adam's account compounds monthly, there's 12 months in a year, so that's 12 times that it compounds. And the interest rate for Adam is 2.4%. So that's just stuff to keep in mind here. But one thing we have to be mindful of is that the rate we have to express as a decimal. So 2.4%, that's just something that I'm going to do this math in my head. I'm doing 2.4 divided by 100. And when we divide 2.4 by 100, it moves the decimal to the left 2 places, giving us 0.024. So this is information we're going to use to write a function for Adam. So we have A of t equals, and then capital P, the principal, is the initial amount invested. So Adam saved $4,000. So that's going to be the P value here. And now we just plug into the formula. So now we'll just write in here, we have 1 plus R is equal to 0.024. Okay, so we have this information here, and I'll just make this a little bit neater. So we have 0.024. And I'll move this over so that we have space to write. And then after this, we just have to account for the rest, that we're dividing the interest rate here by N, and Adam's account is compounding monthly. So we're dividing this by 12, and we're raising this to the 12t power. Okay, so this is Adam's information here. But now we could think about Betty. Okay, so for Betty, we're going to set up Betty's function here, and we're calling Betty's function B of t. And it's nice for this question that they used alliteration, that Adam gets A of t and Betty gets B of t. So for Betty, what we want to be thinking about is Betty's account is growing at a rate of 4% compounded quarterly. So quarterly would mean 4 times per year. Just think there's 4 quarters to $1. So if her account compounds quarterly, that's N equals 4. And 4% is the same thing as 4 out of 100, and that simplifies to 0.04. Okay, so this is just going to set us up to start off Betty's account here. Now, one thing we could do with Adam's account, they didn't tell us to simplify, but if we want to simplify this, we could say A of t equals, and we have 4,000 times 1 plus 0.024 divided by 12 is going to give us 0.002. So this parenthesis term here is going to simplify to 1.002 like this. Okay, so we could just use a calculator to do this, 1 plus this decimal, and we're going to get 1.002, and this is going to the 12t power. So here's A of t, and now for B of t, we use all of Betty's information. Betty saved $3,500, and we're using the same formula here. So we have 1 plus R, Betty's interest rate as a decimal is 0.04. Okay, and we're dividing by the number of times that Betty's account compounds per year, which is n equals 4. So we're dividing by 4, and then we're raising this term here to the 4t power. And now we could simplify Betty's function, and this is going to give us, we have B of t equals 3,500, and then we have times 0.04 divided by 4 is 0.01, so we do plus 1, we're going to get 1.01 now to the 4t power. So here are the two functions, A of t and B of t, and I'll just box them off here, the simplified version. So here's Adam's function, and here's Betty's function, and this is the solution for the first part of the question. For the second part of this question, we're going to use technology to determine to the nearest tenth of a year how long it will take for the two accounts to have the same amount of money in them, and we have to justify our answer. So if A of t and B of t represent the amount of money that Adam and Betty have, we're just going to set these two functions equal to each other and solve for t. But we get to use technology here, so we don't actually have to do the algebra. So I'm going to set 4,000 times 1.002 to the 12t power equal to, and then we have 3,500, and then we have 1.01 to the 4t power. So we could go back over to the y equals, and we'll type in 4,000, and then we have 1.002, and we're raising this to the 12t power, but we're going to use x. And then we're going to write the next part of the equation here in the y2 spot. So we're writing in 3,500, and then we have 1.01 to the power 4t. And now we could press graph here, and notice that we can't actually see anything. And this can be very frustrating. So then go to second graph and go to the table. And notice the trend here, that the first function here, A of t, Adam's account, starts at 4,000 and it goes up. And then Betty's is going up starting at 3,500. So then if we look here, let's see, Adam has more money, and then slowly Betty's account starts to gain until eventually by x equals 9, you see how Betty's account has more money. So one thing to pay attention to is the y values. You see by x equals 10, the y values are all the way up here at 5,211 and then 5,083.8. So I would go to the window and make the y maximum. Let's say I make it go up to 5,500. And now I press graph, and now all of a sudden I could see the two curves, and I could specifically see where the curves intersect. So now I'm going to press second trace 5, and I'm going to scroll to the neighborhood of the intersection point. I don't have to be exact, I just have to get close. And now I just press enter 3 times, and this is going to tell us everything we need. Now, one thing I would do here just to play it safe is I would just draw what the calculator has over here, just a rough sketch, and show that we have two functions here. So we have the first function, and we'll just label this as A of t, and we have the second function called B of t. Okay, so here's the two functions, and I'll just do a rough sketch of what's happening here. So this is A of t and B of t, and I'll just point out here that the point of intersection is occurring at t equals, and we're rounding to the nearest tenth. So if we look over here at the tenths place is a 4, to the right is a 3, so we're rounding down to 8.4. Okay, and if you want to be just extra careful here, explain the button sequence what you did. You could even just say second and then trace 5. Okay, so if you just explain the button sequence that you use to get this intersection point here, that's fine. I'm just writing this to be extra safe. Okay, like this is just really spelling out how you use the technology to get to this answer. And now we'll say, how long did it take for the two accounts to have the same amount of money to the nearest tenth? We'll say it took t equals 8.4, and then we'll just say years at the end. Okay, so for this, if we don't write the units, we're still going to get full credit. but I'm just going to say here it takes 8.4 years. Question 36, on the graph below, draw at least one complete cycle of a sine graph passing through the point 0, 2 that has an amplitude of 3, a period of pi, and a midline at y equals 2. So the first thing I would do here is just plot the point that they said has to be on the graph. So the point 0, 2 has to be on the graph, and I'll just put a 2 here to show that I'm scaling the y-axis by 1. I'm just going to count by ones to go up like this. And then the next thing we should know is the anatomy of a sine curve. So when I think of a sine curve, I just think of this shape over here. So we start here and we go up, down, and then back up. And this just repeats forever and ever, and it repeats going this way. But we only have to draw one complete cycle. They said at least one. If we draw more, that's great, but we're not going to get extra credit for drawing more than one, so we'll just draw one. And now here, it helps to know the anatomy of a sine curve here. So the midline is going to go through all of these locations here. And the midline I just think of as the middle line because the max value is up here. This would be the max. And then the min value, the minimum, is all the way down here at the bottom. So I just call all of these values here the mid values here. So we have the mid, max, back to the mid, then we go to the min, and then back to the mid value here. Okay, and that's one full cycle. We're going mid, max, mid, and then we go min, back to the mid, like this. So here, that's going to be the general shape. Now, don't just do something crazy like this and say, all right, I drew it. This just shows here that you drew one full cycle, but you have no idea what amplitude or period means. Okay, so just make sure that you're drawing this nice. So when we have an amplitude of 3, that tells us the distance between the midline and the highest point, or I could say the distance between the midline and the lowest point. So the midline is at y equals 2. So I'm just imagining here a dotted line going through y equals 2 like this. And now if our amplitude is 3, that means the highest point is going to go up 3 from the midline. So we're going to go from 2 up 1, 2, 3. And that's going to bring us to a height of 5. And we're going to go down 3 from the midline. We're going down to 1, 0, negative 1. Okay, so the minimum value is at negative 1. The maximum value is at 5. Now, the period tells us how long it takes the graph to complete one full cycle. So if the period is pi, that tells us by the time we get over here to pi, the graph will have completed one full cycle. So if I did something like this, just hope for the best and draw this and just maybe draw it a little bit lower, that would probably get us some partial credit, but we want to get the full credit, so let's be as precise as possible. Now, the next big idea is that you take the period and you divide it by 4. And just think that there are 4 sections of a sine curve. So you can look at here, I'm going up, I'm going 1, 2, 3, 4 like this. So I would take pi and divide by 4, and that tells me that I'm counting by pi over 4s. And notice that pi over 4 is halfway between 0 and pi over 2. If I were to I'm just doing this math in my head, if I take half of pi over 2, I do 1/2 times pi over 2, that's going to give us pi over 4. Okay, so that's the first point that I'm plotting after 0, 2 is going to be at pi over 4, and that's going to go up to the max. Remember, it's mid, max, and then we're going back to the mid, but we're jumping by pi over 4. Okay, this tells us how much to count by. We take the period and we divide by 4. So we're going over pi over 4 up to the max, and then we go over pi over 4 back to the midline. We go over pi over 4 and we go down to the minimum, and then finally we go over pi over 4 and go back to the midline. And notice that this gives us one full cycle of the sine curve. So here is our sine curve. Now for the last part of this question, we have to use our graph and state an interval in which the graph is increasing. So the graph is increasing where the graph is going up. So I'm noticing right away at this part of the graph is increasing from 0 to pi over 4. And then from pi over 4 to halfway between pi over 2 and pi, which we could say is 3 pi over 4, the graph is decreasing, and then it increases again from 3 pi over 4 to pi. But once again, we only have to state one interval in which the graph is increasing, and the easiest one to state is, it looks like the one in the beginning here, that from 0 to pi over 4, which is halfway between 0 and pi over 2, from here to here, the graph is going up, so I could just say from 0 to pi over 4 like this. And here would be our solution. We only have to state the interval. We don't have to explain or justify how we know. We just have to state it. If you were to put brackets here, they would still give you the full credit, but I'm putting parentheses. I like to use parentheses because technically at pi over 4, that's the turning point where the graph is neither increasing nor decreasing. So I like to exclude the endpoints here, but either way, we would get full credit. So this gives us our solution to question 36. Now, one extra thing I want to point out, if we actually had to go the extra step and write an equation for what we graphed over here, we could use this formula over here where A is the amplitude, B is the frequency, and C is the midline. So for this one, it would be easy to start off just saying A, the amplitude, is equal to 3. So I would start off with 3 times sine of, and then B represents the frequency. And we could use this formula here, 2 pi divided by the period is equal to the frequency. So for this one, what I would do is I would just take the period pi and say that our frequency, and I'll just call it lowercase b here, that our frequency b is 2 pi divided by the period is pi. So that gives us a frequency of 2. So then I would have 3 sine of 2x, and then plus our midline is at y equals 2. So that's our value over here. And let's see what happens when we graph this. So let's go over to mode first and switch the calculator over to radians. And now we go to the y equals, and we'll clear out what we had from before. And we're going to write in, we have 3 times sine of 2x, and then we have plus 2. And if I press graph, the calculator is all out of whack from before. So the first thing I'll do is just press zoom 6. And it gives us a whole bunch of stuff over here. But now what we could do is we could just switch the x minimum and maximum to go from 0 to pi. So I'm going to go window, I'm going to go from 0 to pi first. And then I'm going to make my lowest point at -1. So I'm going to switch my y minimum to -1. And my y maximum is going to go up to the max value here, 5. And if I did this right and I press graph, I would see that we get exactly 1 full cycle. And if I put the midline in at y equals 2, and notice that the midline does cut this graph in half. One thing we could also do is we could scale it to count by pi over 4. If I go to second window and I change the delta table to pi over 4, I'm going to go pi over 4 like this. We could then go to the table and see the values that we get. And notice that we get 2, 5, 2, -1, 2. Notice we get 2, 5, 2, -1, 2. And if I go over to the window and I switch the x scale as well to pi over 4, watch what happens now when I press graph. You could see here that at pi over 4, we're at the max. At pi over 2, we're at the midline. 3 pi over 4, we go to the minimum. And then at pi, we go back to the midline and complete 1 full cycle. So now we move on to part 4, the final boss, and this question is worth 6 credits. Take a moment to read through question 37. The first thing we have to do is graph p of x over the interval 0, 9 on the set of axes below. So let's go over to the y equals, and we're going to type our function in here. But remember, before when I graphed the trig function, I changed the window settings and I changed the table set. So if you don't want to mess around with these settings again, what you could do is you could press second plus to bring up the memory, and then press 712, and that will reset the calculator and put it back to standard form. So that's just going to put everything back to normal. Otherwise, you have to know to press second window and make sure your table is starting at 0 and you're counting by ones. So now I'll go over to y equals and type in p of x. We have -x to the third, and then we have plus 11x squared. And then after this, we have -7x, and we have -69. And they told us to graph this between 0 and 9. So when I go to the table, I press second graph. Notice that from 0 to 9, we're going from -69 all the way up to the maximum value in the table right now appears to be 78. So if I want to capture all of this, I could just press graph and look at what we have so far. But if I want the graph to be as accurate as possible, I'm going to go down to, let's say, -75, and I'm going to go up to 85 so I cover all of this. So here I could just go x minimum 0 and then x maximum 9 because I only need to look at the interval from 0 to 9. And then we said, let's go down to -75 and we'll go up to 85. And if you ever need to adjust this, you could always press graph. And if you don't like how it looks, you could just readjust it again. But we're going to use this picture and the table of values that we have here to help us get the most accurate graph. So now I'll just copy down the table, plot the points, and connect them with the curve. So here is our graph of p of x over the interval 0, 9. Before we go on to the next part, I just want to add a little more detail to this graph based on the context of the question. So p of x models the profit of a manufacturer. The manufacturer is making sweatshirts, and this function p of x is a function of the number of sweatshirts sold x in thousands. So I just want to point out here that x represents the number of sweatshirts sold. I'll just say the number of shirts sold. So x is the number of shirts sold, and we're counting by thousands. This is very important because when we get to the next part of this question, if we ignore that part, it's going to throw our answer off by a little bit. So the next thing to consider is that the profit p of x is also represented in thousands. P of x, the units are thousands of dollars. So the y-axis over here, we're talking about thousands of dollars. So this is just something, once again, we have to keep in mind when we move on to the next part of this question. So now for the next part of question 37, we have over the given interval, which is going from 0 to 9, we need to state the coordinates of the maximum of p and round all values to the nearest integer. And we have to explain what this point represents in terms of the number of sweatshirts sold and profit. So if we want to find the maximum of p, all we have to do here is press second trace, and we go to maximum, which is option 4. And we scroll over here to the top of the hill. We go before the top of the hill and we press enter once. And then we scroll past the top of the hill. We press enter a second time and then a third time. And this is going to give us the maximum value of the function. So now we can write down our solution. And remember, first we have to state the coordinates of the maximum of p, and we're rounding to the nearest integer. So here the maximum occurs at the point 7, 78. So first we just have to state the coordinates of the maximum, and here it is. And now I wrote down a description of the x and y axis before, and we're going to use that to help us explain what this point represents in terms of the number of sweatshirts sold and profit. So the x-axis was the number of sweatshirts sold, and we're counting by thousands. And the y-axis, the units are thousands of dollars. So if we think about this here, 7 would represent 7,000 sweatshirts are sold, and the 78, we would say $78,000. So now if you piece it all together, what this means in the context of the problem is that if the manufacturer sells 7,000 shirts, 7,000 sweatshirts, they're going to make a maximum profit of $78,000. And now for the last part of this question, we need to determine how many sweatshirts to the nearest whole sweatshirt the manufacturer would need to produce in order to first make a positive profit, and we have to justify our answer. So look at this graph over here and think about, when does the manufacturer first make a positive profit? That would be when the graph enters the positive, when it goes above the x-axis. So that's going to first happen when we go past this point here. Okay, this is when the profit is equal to 0. This is when the profit is negative. So we'll say p of x in this location is less than 0. Over here, p of x is equal to 0. And then finally above, in this section over here, p of x is positive. And if you just think about it logically, if the manufacturer doesn't sell any sweatshirts, then they're just going to owe money because they still have to pay the workers. They have to pay the bills on running the facility where the sweatshirts are made. It's only after they sell a certain amount that they begin to turn a profit. And we're going to use the calculator to find when this happens. So if I just want to find the root here, all I have to do is press second trace and then option 2 for 0. And I scroll over to the root, and I'm going to go before the root and I'm going to press enter. And then I'm going to scroll to the right of the root like this and press enter a second time and then a third time, and I get, this answer over here. Another way to do this, you might like this way more, is you go to y equals and you graph the line y equals 0. And now I got this red line over here. And then I could just trace the intersection of the blue and the red. I just do second trace number 5. And I go near the 0 line over here like this. And I just press enter 3 times and I get the same exact answer. But, choose which way you prefer to do. They both will give you the number that you need. So now let's just record what the calculator told us. We have p of x is equal to 0. And we'll say when, and then we just write down the x value here. When x equals, and we have 3 point, and we have 5, 4, 8, 8, and then 3, 9, 8. And now let's just think about this. how do we interpret this in the context of the question? We want to know to the nearest whole sweatshirt, how many sweatshirts have to be sold for this manufacturer to first make a positive profit. So just think about this very carefully. We talked about this before. We said the x-axis, the units, are in thousands. So that means here that we have to multiply this decimal by 1,000. And if we multiply by 1,000, we just take this decimal over here. We have 3 point, and then we have 5488, and then we have 398. If we multiply by 1,000, that's going to move the decimal 1, 2, 3 places like this. So this is the number I have in mind, 3548, and then point, and then we have 8398. And I'll just write 0.8 like this. So now think about this very carefully. This is the moment when the function p of x is equal to 0. So I'm thinking of the two whole numbers that this decimal is between is 3548 and 3549. So at 3548, let's say we rounded down, even though 0.8 tells us to round up, if we stop at 3548, we would be slightly in the negative, okay? At 3,548 sweatshirts, that would be less than this value here, and we would be in the negative. But if we go to 3549, if we go up, then this would be the first whole number bigger than this that would put us in the positive, okay? Remember, the x-axis, we're talking about the number of sweatshirts sold in thousands. That's why we have to multiply these values by 1,000. So how many sweatshirts would have to be sold to first make a positive profit? We would say 3,549. Now, one more thing I'll add just to be extra safe is I'll just mention how I came up with this number. I'll just write out the button sequence here, second trace 0, to point out how I found this value over here. Okay, so I'm just going to write this in, and I'll draw an arrow here to show how this value came to be. But this response here would get us full credit.